Welcome, my dear students. It's nice to meet you after the holiday. I hope you to enjoy with your holiday. And I hope also to enjoy our program. Take care. This year we have important terms. Some of them about the physics and other biology. Do you think you are ready to work with us? Let's see what we can do. The first one about motion. Force and motion. To explain this, you must look at this. The car starts to move. The motion here is from the beginning and fly. This can be, yes, sometimes can be, but notice something. We have a starting point. Do you know what this means? You have a motion and the car moves by its force. The motion, it's up, as you see, move in a straight line. Also can fall down. All of them, it means motion from starting point to ending point. What this mean? It means you have motion. It's good to explain that. Motion. To explain this word, you must know everything. It has a motion. The car starts to move. Oh, it's motion. The other, it starts to move. It's motion. But I ask, what is meant by the motion? Motion, movement of the object, has a starting point. This we need, has ending point. So, the motion, it means movement with starting point and ending point. Can be up, can be down, can be in different directions. Yes, this is the motion. Motion in one direction. This it means what? The motion here, it means move forward only. Sure not. Also, we can move backward. Both of them motion in one direction. Let's see that. It's motion in which the body moves forward and backward. But notice something. Don't move up and down as we saw before. So, up and down, motion only. But here, forward and backward. Motion in one direction. In one direction, it means we have a big difference between the first and the second one. It means the car starts to move, but I see it moved forward. Yes, motion in one direction. Maybe move backward. So we can say motion in one direction. But I can't move here up and down. When I move up, when I move down, this it means the other type of the motion. So the motion in one direction, forward, backward. Maybe as you see in a straight line. How can you see that? When you see this ruler and the car start to move, the other move in the opposite direction. Both of them in a straight line. It means motion in one direction. So this motion straight line. No, the motion can be in the opposite, can make a curve. So this type is curved motion. Also we can say this curved motion, motion in a straight line. Curved motion, straight line motion, curved and straight line in the same time. It's good to say that. This is the motion. Example of the bodies move in one direction. As a beginning here, we have train motion. Yes, train move forward and backward. It's good to say motion in one direction. Also, car motion. This only? Sure not. Also, we have bicycle motion, people motion. All of them motion in one direction. When I say the motion, curved or straight or so on, so it has many physical quantities depend on different things. As I need a distance. The distance here, as you see, 20 centimeters. So we have another 20. we have third 20. This it means I have equal distance. But in the same time, this equal distance has an equal time. Here we have about 10 centimeter in 1 second. Another 10 in another 1 second. Third 10 in another second. Do you think what this means? This is called good uniform speed that we need. You have here example for the special physical quantities that the motion depend on. As you see for the number 1, meter per second. Do you know what this means? It means unit of speed. It's good to say that. Another physical quantity, kilogram. Kilogram here it means the measuring unit for the mass. Also meter. This is for the distance. But we have the important one, second, for the time. All of them it means what? Special physical quantities. My dear, look at this. When I say the types of the motion in one direction, you can catch many things. As a beginning for the first one, when I say motion in a straight line, this is the simplest kind of the motion. You must know that. Simplest one, forward, backward. It's good to say that. Also, we have motion in the curved line. We have motion curved and straight together. This it means the motion is differ from one to another. Straight line, curved line, both of them. It's good to know it. Here we have the opposite. The car starts to move. Yes, we have 20 centimeters in 2 seconds. Oh, I have 5 centimeters in the same time, 2 seconds. Another 7 centimeters in another 2 seconds. The distance here is not equal. Do you think what this means? This is called non-uniform. This is not only, I can get here 2 centimeters, 1 second. Another 2 centimeters, but here in 4 seconds. Another 2 centimeters, but the time is different, 10 seconds. So the different in distance, different in time, this it means good to say non-uniform speed. Darling, concentrate. Speed. Do you think what this word? Speed here is a physical quantity. It means distance moved by the body in 1 second. Speed. Do you think speed has this definition only? No, we have another definition when I say distance moved by the body per unit time. Sure, we catch 2 important words, distance and time. Do you think are important? Yes, let's see this and see what is the speed. This motion for the girl with a dolphin. The motion here, it moves through distance. The distance may be short as you see and move step by step, slowly. But here the distance are equal, the time is equal. So, it becomes faster. Do you think the motion here is changed? I think, yeah, there is a change here. It means there is change in speed. Also, the shape of the motion is changed, as here is a curved one. Also, straight and curved one. The differ from one to another here, it means motion can be changed according to change, good, distance and time. Can be through cars, through animals, through human, through different objects. So, the main physical quantity here, it means speed. As a funny video, as you see, there's a motion also. Straight line, it's curved one. So, all of them different type. All of them different shape. It's good to know that. What about to see this? Good, my dear. You say it's curved. Good. Straight. I know. So, catch all of them. Now, what is the law in triangle? Law here for the speed. Yes, it has a law. Look at this triangle. Oh, I have different triangles. The first one has a D, V, and there is a space. Yes, do you think what this is space? Good, my dear. I hear someone say it's T. The other one, V and T. And you have a space. What do you think? This it means good. It's a T, up, D. So last one, D and T, so you have V. Look at the first one. No, nothing. No, we have a T. Nothing. No, it's D. Third, yes, good, it's a V. So the total shape, the total law will be D, T, and V. D, V, T. It means distance, time, and speed. My dear, we work through the problem. Let's see example number 1. Here we explain how can you answer problem. Body moves 100 meters in 2 seconds. Find the speed. How can you catch this? My dear, get your given and work as a steps. The first one, D equal 100 meter. You know? Good to say. This given only? No, we have a T. T here it means 2 seconds. It's good to catch it. What about the other? The other here I need a V. Write the law. Problem without laws equal 0. V equal what? D over T. Also we can say delta D over delta T. It means a change here. Now, what about to substitute these letters by number? V equal 100 per 2. Do you think what is the answer? Good. 50. 50 what? 50 meter per second. Don't forget, without unit here, there is no complete degree. So 50 meter per second. My dear, what about to get the other example to help me to get a full mark? Look at this. When you say car moves 600 meters in half minute. To car, you have a new word, half minute. Calculate the speed. It's easy. Now, number 1, get your given. Good. The first, D equal what? 600 meters. T equal half minute. Oh, it's not well. Why? Because we work through minute. Change it to second. Equal 30 seconds. That's what we need. Change. If you have a minute, you must change it to second. Half minute, 30 seconds. 1 minute, 60 seconds. Now, what you have? Good, my dear. You can write the law. Here, V equal D per T. It means delta D over delta T. Can be. Why not? The answer here, 600 per 30. What's your answer for this case? Directly we catch this. Look, 20 meter per second. It's good to say that. Now, what about the factors that affect for the speed? I think these factors, you understood it from different things we explained. As for the first one, when you say time, good, no speed without time. The time need a speed. Speed need a time. The other one, it means a speed is inversely proportional with the time at constant distance. Why we say that? Because we study the law dVt. You have a D, you have a T, you have a V. Fixed one, change the other. Look at this. We have a distance. Distance from the important factor also that affecting for the speed. You know the distance, it means speed directly proportional with the distance at constant time. Take care and concentrate. my lovely students, the main factor what and what? Distance, time. We know from where? From the law. My dear, when I say the factors, directly back to the law. The law here, it means the main factor, dVt. Distance, I need a distance. Change the other factor as a v and t. If you need a v, what you say? What is the other factor? Good, to say distance and time. Third one, you need a t. Change distance and v. So don't give factor, but try to understand what you need, the factors from where? From the law. It's good. Look at this. You have the first d, v, and t. Don't say more about that. D by meter. This is the unit. We can't work without unit. The unit for the distance here, it means meter. Yeah. What about t? Second. What about v? It's easy to say meter per second or kilometer per hour if we change d and t. It's a good lesson and easy to understand it. What about to get example to tell me about that? The example here, he say, 2 cars. The first car moves by 100 meters in 1 second, while the second car moves 50 meters in 1 second. My question, which of the 2 cars is faster and why? We learn it from our work. Look at this. The first car is faster. How can I know? The first faster than the second one. I know here. Why? Because the first car cuts larger distance than the second as the same time. Here there is no change in time, but the distance for the first greater than the second. Directly you can say first is faster according to distance. Lovely lesson. What about to ask you? You must say speed here directly proportional with what? With the distance. This to help us to know the relationship between speed and distance. In the same time, my dear, you have another example. 2 cars. The first moves 100 meters in 1 second, while the second one moves 100 meters in 4 seconds. My dear, which of the 2 cars is faster and why? Yes, you know the answer. Here we can say the first car also. Oh, the first car, distance here equal distance over time. We know that the distance by 100 time by 1. So 100 per 1 equal 100 meters per second. What does this mean? I have here what? I have here good speed. What about the other car? The second car by the same steps. The law distance per time. It means 100 per 4. What you say now? We can say 25 meters per second. Now, which one is the faster? Good, my dear. We can say the first car faster than the second. But you must say the reasons. What is the reason for that? The reason here it means because the first car takes shorter time than the second car at constant distance. Good. Main factor is a constant. The other is a changed. So complete your answer. Speed is inversely proportional with the time. Take care. This relation is important to compare between the different speed for the cars. Look for the other one when I say train motion. Train motion, yes, we know it's motion in a straight line, but train motion, straight line, may be uniform speed. Yes, I know. Maybe non-uniform speed. Yes, also we know. Maybe uniform speed relative to the other train. My dear, what you do here? Let's see and look. Look at the first car. The first car move fast, as you see. It's good to say that the speed of this car now, it's about 20 kilometers per hour. For example, we say that. The other car moves slowly, 5 kilometers per hour, but it needs long time. Oh, when I say, what is the difference between the first car and second car? The difference here, about 20 minus 5, it means 15. Do you know why? Because both of them move in the same direction, relative speed. It's good to catch this. Regular speed, it means uniform speed. Regular here, it means equal. Equal for what? Look at this. It means the body moves equal distance in equal periods of the time. Distance and time, both of them are equal? Yes, we know. It's good. I go to school every day. It means 2 kilometers in 1 second. Every day, 2 kilometers in 1 second. It means good, regular speed. Example. The example here, look at this car. The car starts to move about 3 meters in 1 second. It's good, we know. Another one, yes, 3 meters in another 1 second. What is the difference? No difference here. The third one, good, 3 in 1 second. Every time, same distance, same time. It means I work it through regular, uniform speed. It's good to catch them. This example, the body gets equal distance in equal time. Also, irregular speed. Irregular here, it means difference. Difference what? We will see irregular speed, non-uniform. The two cars start to move, but in opposite direction. The first, 20 kilometers per hour. The other one about 5 kilometers per hour, but moves in opposite direction. Do you think what this here? This here it means you have about 25. 20 plus 5. Why we say that? Because both of them in the opposite direction. We say summation 20 plus 5 equal 25 kilometers per hour. It's good to catch all of them. Body moves an equal distance in equal period of the time. Also, it means we have an example. We have a crazy car. This our crazy car 4 meters in 1 second. What else? Look at this. Oh, there's difference for the distance. 2 meters in 1 second. The time is changed? No. But distance is changed? Yeah. This it means the other motion 3 meters in 1 second. So, distance here, good. Is it changed? But the time is not changed. This it means you work through irregular, non-uniform. It's good, my dear. In this example, the car, non-uniform speed. Why? Because it moves equal distance in equal period of time. My lover, what about to see the other example here about irregular? The crazy car also start to move 4 meters in 1 second. The other motion 4 meters 5 seconds. Oh, what is the difference here? The difference here not for the distance, but the difference here for good, for the time. Time, why? Because time is not constant. 1, 5, also 3 seconds. This it means equal distance and equal time. Do you know what this means? Good, my dear. It means non-uniform speed. In this example, the car moves with non-uniform speed, irregular. Why? Because it moves equal distance in an equal period of time. It's easy and lovely lesson. What about to get this note? Note especially to help me to understand what I learned. Look at this. Irregular speed is considered as average speed. I think it is the first time to hear the word average. Average between what? Between the motion. Because we depend on the total distance moved by body dividing by the total time. Total distance, total time. Do you know what this means, my lovely students? It's average speed. It's a good name and good word. Look at this. When I say definition for the average speed, yes, we know total distance, total time. It's good. V equal total distance over total time. We can see here for this, look, if the average speed equal the uniform speed, this means that the motion of the body is uniform motion. Why we say that? Because both are equal. Uniform equal average. Directly we say uniform speed. Now, the unit of the speed is meter per second. Yes, we can say that. If we have small units, small meter, small second, yes, I know, so meter per second, or the huge one, kilometer per hour. This it means the unit of speed, unit of average speed. Any word contain the speed, this is unit. My dear, I explained the lesson and I hope to understood it. The lesson, it has many steps. Take care. I need to work step by step. How can you catch a problem? How can catch law? This our aim. See you soon. Thank you and goodbye.